The probabilistic analysis tool allows network assessment based on probabilistic input data, rather than assessment of individual operation scenarios or time sweep analysis. It becomes important as soon as input parameters are known to be random, or if one wants to simulate the grid at some time in the future with forecast errors. A probabilistic assessment processes probabilistic data input and produces stochastic results. Thus each result quantity will no longer be a fixed number but a distribution from which statistic quantities, for example mean values, standard deviations, min, max, etc. can be derived. In the example, the distribution of the line loading, resulting from the power generation of the wind turbines based on the wind speed distributions, is shown, from which the statistics can be derived. Probabilistic analysis is offered for load flow analysis as well as optimal power flow. In this video, we will take a closer look at the probabilistic analysis of load flow. In the first step, we want to analyze the effect of forecast errors of wind power data on the network. A study case in this example has been prepared for this purpose. For the probabilistic analysis, distribution functions are necessary. We will assign a normal distribution to the active power value of a wind generator, in order to consider a forecast or measurement error. For this purpose, we right-click on the active power value, which is already modified by a characteristic, and select Add Project Distribution. All available distributions, like uniform, Y-bowl distribution etc. will be shown. We select Normal Distribution. A normal distribution has already been defined with a mean of 0 and a standard deviation of 5. A random value that is drawn from the distribution is applied additive in % to the characteristic value. Different representations of the distribution can be selected. For the next steps, we need tools that are available in the probabilistic analysis toolbox. Before we run the probabilistic analysis, we have to define result variables that are to be recorded during the execution. We can differentiate between statistical and sample results. The result parameters for the active and reactive power have already been defined for static generators. We can now run the probabilistic analysis. The command is accessible via the probabilistic analysis toolbox. We will analyze the load flow probabilistically. For this, we will use the Monte Carlo method with 10,000 samples. On the recorded statistics page, we can define which statistics are to be recorded for the selected variables. We are now ready to execute the command. After the calculation has finished, the results can be analyzed. In our example, we are interested in finding the line with the highest average loading. For this purpose, the Network Model Manager is a very helpful tool. Open the Network Model Manager and filter for lines. Go to the Flexible Data page, where some parameters have already been defined. Let us sort the lines by the mean of the loadings. This line has the highest loading. Another way to analyze results is by plots. Plots for the probabilistic analysis can be created via the Create Plot icon. Different plot types are available. We will create a distribution estimation plot. In this example, we can delete the first row, since we want to represent the curve as probability density function that is estimated via the histogram method. As element we select the grid sub 05 and max loading as the parameter. The diagram shows us the frequency distribution of the maximum loading in the network. Since only normal distributions have been used in this network, this curve also reflects the shape of this kind of distribution.